Hi everyone, in this video we have two examples. In the first example you have to find limits including natural logarithmic function, and in the second example you have to find limits including exponential functions. So in example 1 part A we have limit Ln of 3 over x cubed divide when x goes to positive infinity. By direct substitution you will see that we have a 3 divided by infinity cubed, and infinity cubed equals to infinity, and any number divided by infinity or negative infinity equals to 0. For the second example we have limit Len of 3 over x cubed when x goes to 0 from right. So by direct substitution you will get 3 divided by 0 from right cubed, and 0 from right means a number a little greater than 0, so it will be positive, and when we have cubed it means 3 over 0 to the right, and this is give us plus infinity. So our limit equals to len of positive infinity, and len of positive infinity equals to positive infinity. In part C we have limit len 2x over len 3x when x goes to positive infinity. So here you have to use the properties of the Ln function, and as you know len a times b equals to len a plus len b. So here we have len 2x in a numerator, so you can write it as len 2 plus len x divided by len 3 plus len x. Now you have to divide a numerator and denominator by len of x, so divide up and down by len of x divided by len of x. So our limit will be limit of len 2 divided by len x plus len x divided by len x over len 3 divided by len x plus len x divided by len of x when x goes to positive infinity. So by simplifying we have len x divided by len x equals to 1, and here we have 1, and as you know len 2 is a number and also len 3 is a number, so we have by direct substitution len 2 divided by len of infinity, and len of infinity equals to infinity, so plus 1 divided by len of 3 divided by infinity plus 1. Since len 2 and len 3 are constants, any number divided by infinity equals to 0, so we have 0 plus 1 divided by 0 plus 1, and the answer of this limit equals to 1. In part D you have to use the quotient rule of logarithmic functions, and the quotient rule mean if we have len a divided by b, this gives us len of a minus len of b. Now we have len minus len in our part D, so we have len x squared minus 1 minus len x minus 1, so we can write this in one natural logarithm. So the limit will be like this. len of x squared minus 1 divided by x minus 1 when x goes to positive infinity. Now, since the len function is continuous from 0 to infinity, you can enter the limit inside and you will get len of limit x squared minus 1 divided by x minus 1 when x goes to positive infinity. Now, since we have limit polynomial divided by polynomial, you have to take the highest, when x goes to infinity, you have to take the highest power up and the highest power down, and you have to cut the other terms. So here you have to cut minus 1, and here you have to cut minus 1, and you will get len of limit x, because x squared divided by x equals to x when x goes to positive infinity. Now replace infinity in x in our limit, you will get len of positive infinity, and this is equals to positive infinity. In example 2, you have to find limits with exponential functions. So in part A, we have limit e to the power 1 over x when x goes to positive or negative infinity. So by direct substitution, this is equals e to the 1 over plus minus infinity. Now 1 divided by infinity or 1 divided by negative infinity equals to 0. So we have e to the power 0, and as you know, e to the power 0 equals to 1. For the second part, we have the same function e to the power 1 over x, but x here goes to 0 from right. So by direct substitution, this is equals e to the power 1 over 0 from right. Now any number divided by 0 equals infinity or negative infinity, but since we have 0 from left, we talk about negative numbers. So it will be e to the negative infinity. And as you know, e to the power negative infinity equals to 0. So this limit equals to 0. In part C, we have the same function also, e to the power 1 over x, but x goes to 0 from right. And by direct substitution, this is equals to e to the power 1 over 0 from right. And 0 from right means positive number. And 1 over 0 equals infinity or negative infinity, but since we have 1 over 0 from right, this means we have e to the power positive infinity. And e to the power positive infinity equals to positive infinity. In part D, pay attention that we have the exponent cosecant x. And as you know, cosecant x equals cosine x divided by sine x. So by direct substitution for the function inside, we have e to the power cosine 0 from right divided by sine 0 from right. Now sine 0 from right equal 0 from right, because we talk about first quadrant. 0 from right means the angle in the first quadrant. So the sign will be 0, but 0 from right. So we have e to the power, about the denominator, we have 0 from right, and cosine 0 from right equals to 1. So we have e to the power 1 over 0 from right, and this gives us e to the power positive infinity. And e to the power positive infinity equals to positive infinity. In part E and F, we have nearly the same ideas. Now you have to divide numerator and denominator by e to the power x firstly. So this is the first step to find the limit in part E. Divide by e to the x, divide by e to the x. So we have limit e to the x divide by e to the x plus e to the power negative x divide by e to the power x, and denominator we have e to the x divide by e to the x minus e to the power negative x divide by e to the x when x goes to positive infinity. Now e to the x divide by e to the x equals to 1. Also here we have 1. Now e to the power negative x divide by e to the x, as you know, x power m, x power m divided by x power n equals x to the power m minus n. So when we divide, you have to subtract the exponents. So the limit will be 1 plus e to the power negative x minus x negative 2x divided by 1 minus e to the power negative 2x when x goes to positive infinity. Now by direct substitution you'll get 1 plus e to the negative infinity over 1 minus e to the negative infinity, and this is equals to 1 plus 0 divided by 1 minus 0, and the final answer equals to 1. In part F we have limit 2 to the x plus 3 to the x over 2 to the x minus 3 to the x when x goes to positive infinity. Here with the same procedure in part E, you have to divide by 3 to the x or 2 to the x, but here you have to divide by the biggest number, which is a 3 to the x, because we have this rule: if we have a fraction to the power infinity, this is equals to 0, but a divided by b must be less than 1. So you have to divide by 3 to the x, up and down. So the first step, divide by 3 to the x, divide by 3 to the x. Now the limit will be limit 2 over 3 to the x, you can combine the power, plus 3 over 3 to the x, and in denominator we have 2 over 3 to the x plus minus, have minus here when x goes to positive infinity. Now for 3 over 3 to the x, this is equals to 1 because we have 1 to the x, and here also we have 1. Now by direct substitution and by this formula, if we have a fraction less than 1 raised to infinity, the answer will be 0. So 2 over 3 to the infinity plus 1 divided by 2 over 3 to the infinity minus 1, and this is equals 0 plus 1 divided by 0 minus 1, which give us negative 1, and that's it.